Good afternoon, everyone. Can you hear me okay? Perfect. Awesome. Thanks for joining us this afternoon. So we're going to speak about AMD software stack ROCm, and more importantly, a pervasive software platform that goes from client to cloud. So we're going to talk about speed of execution in the era of AI, and why execution speed matters most. Then we'll talk about the ROCm stack itself, unified AI software layer, which is fully open source and is available for everyone to hack on, move at the speed at which you can execute, and then talk about some tidbits about AI in production, right? So why is speed the moat? So I think one of the things that we got to recognize is previous platform shifts took years to play out. Mobile, internet, all of this were it played out over years, and you could actually adapt to it over multiple months of processing such a change, right? If you looked at the mobile transition, cloud, all of them were multiple years in motion. But this time it's happening in mere months or even weeks. Something that was really important last week is no longer important today, right? Models that that everyone was talking about is I don't know if people still remember, even 6 months ago, RAG was the thing, right? And now it's if you ask someone RAG, they're like, what RAG, right? And it's moved on so fast. So the advantage is not the technology itself. The advantage is how fast you can adopt to the technology. And when software becomes tokens, the advantage shifts to execution velocity, right? And so what we want to focus on is execution velocity. And at AMD, we are super dialed into this to make sure that, one, you have all the tools, all the software, and the ability to act at that speed. And increasingly what happens is, what you used to do for regular syntax implementation, all of that kind of disappears, and value moves upstream to intent. So you start with what you want to do, and you define what that is, and then let agents operate for you, right? And then that is also why you can massively parallelize. The wingspan of what strong individual contributors are able to do is immense. It's like multi-threading in a AMD CPU core. You get so many threads to operate on, and each one is operating for you continuously. And all of this compounds, right? And so when you execute in parallel, what you're doing is you're actually evaluating in parallel, you're building in parallel, you're testing in parallel, and all of this moves fast, and then that starts to compound with the feedback brought into the entire pipeline. So let's take a look at what AMD's software stack and hardware stack looks like. So AMD's hardware is pervasive. AMD is uniquely positioned in laptops, desktops, workstations, edge AI, physical AI, cloud, and data center. Across the entire spectrum of compute, you have AMD's presence. With this pervasive AI hardware layer, now what we're doing is building a pervasive software layer. And so what this provides us is the ability to operate not just in your personal space, on your laptop, on your desktop, but increasingly, to burst into other areas of compute, like the cloud footprint or AMD Instinct GPUs in your data center. So ROCm itself has a deep philosophy that we all rally around, right? Which is it is open. We strongly believe that open source allows us to not just move fast, it lifts the boat for everyone, right? It's a common good. And so the philosophy of open is very important for us at ROCm. And then increasingly what we had been investing in is abstractions, right? Whether it's kernel programming, inference engines, serving. And what this provides us is the ability to kind of give you the right layering for developers to rely on our SDKs and our platform without having to worry about the details. And when you get to things like kernel programming, using languages like Triton allows you to get away from very, very deep nuances of the GPU or for you to build on top of ONNX runtime Gen AI. There are some banner numbers with this. With the new ROCm EP, we see about like 3x faster prefill and about 40% faster decode using the ROCm EP. And I think that will have an immediate impact in anyone using AMD GPUs. It also supports unified memory on Ryzen AI for APUs and up to, and for models even larger than 100 billion parameters. And the impact of all of this is that you can enable a variety of dense and MOE models on AMD platforms just seamlessly. So with that said, let's talk about a little bit more on use case-driven routing solutions. This is a very interesting and exciting topic because, until now you had to choose. You had to either use a frontier model, and I'm sure you dread seeing the user limit when you hit it, or the API throttling on the other side. It's not your problem. It's still the service is throttled. So what we have built is like a solution that can start with seamlessly like processing your intent and then routing to either local LLMs or to cloud providers, not just for cost reasons, but also for privacy reasons, and being able to like give you a scalable burst capacity of thinking, burst capacity of just cost even, right? Like it's like when you need to do your quote unquote ultra think, it's okay to go to the frontier model. But for most of your SED and search and grep, it can all run locally, and you can save a lot of API calls just going up to the cloud. So what we're going to do in a couple of slides, we're going to show you a demo of this. But yeah, so this gets you the ability to go from different prompts and go through your semantic router, your 𝗦𝗲𝗀𝗻𝗃 SDK, and then to the corresponding backend. So just walking that forward a little bit, this is a little overview of how we would be doing hybrid workflows. And so your client applications, which are your web, email, internal tools, etc., use your normal OpenAI endpoint, and it is terminated on your on-prem proxy with the VLLM semantic router. And then that allows you to select which model you want to hit in the backend. And that pairs up with the 𝗦𝗲𝗀𝗻𝗃 router. And that gives you the ability to choose, based on the complexity, the task, which of these models you want to pick up, right? And that could be your Qwen 3.5 or any cloud frontier models that you want to leverage. So now that we have this, let's see if we can see this in a live demo. I'm going to get Satya on stage. Satya, come on.
Thank you, Anush. So this is a live demo of what Anush has just shared. So for this, we're using VLLM semantic router. It's an open source framework from VLLM. So what it essentially does is it takes an LLM's text and then routes it to a right model at the right time. So it does this using a predefined configuration file where we define our routing logics. So as you can see here, we have a bunch of layers where we define domains, keywords, and complexity, context length. And then, like Anush was saying, we also define our jailbreak and PII prompts. And based on these routing layers, the router decides where a specific prompt has to go to. So we have three models loaded here. One is for classifying a given prompt into 14 different domains like computer science, sociology, or biology. These are some of the examples. And then we also have a jailbreak detection and also PII detection. So this is the brain of the VLLM semantic router. So if we take a look at So if we take a look at one of the layer where we have jailbreak and PII, so this gets routed to a local model running on the Ryzen AI laptop. And for any other complex prompts, it gets routed to a cloud model where we have Azure plugged in. So if we go to the playground, and then I'll start with a simple prompt like my phone number 9. No. So the idea is, since I'm sharing the private data, it is supposed to go to a local model. So as you can see, it flagged it as a sensitive PII, and then it went to a Lemonade server. So this is an open source server that we built at AMD. It runs efficiently on our AMD hardware. And as you can see, it loaded a 𝗦𝗽𝗀𝗀𝗀𝗃𝗀 model, and the entire prompt got processed locally. Now, if I send a complex question, which might not need a local model, so the idea is this should go to a cloud model. So in this case, it's going to a GPT 4.1 mini. So this is hosted on Azure, and we can efficiently tune our configuration file, this brain, to route our questions between any set of models, as long as the model is exposing an endpoint. Let's go back, and still running. Yeah. That's it. Thank you.
Thanks, Satya. Thank you. So I hope that was not your real phone number. But as you can see in the demo that Satya showed us, right, we have, I think, is that good? That's still the demo. Oh, that's okay. So as you can see in the demo that Satya showed us, the ability to like semantically choose which model you hit and where you hit is an important part of our overall client to cloud story. This allows you the flexibility and the security to use the models that are most relevant for your task with the safety guards that we want to have in place, like your phone number or social security number that you don't want to expose in a public setting. With that said, I think our key takeaway message now is like software is now tokens and time. And what that literally means is, if there is any gaps in anything that you see which is attributed to software, it is a matter of time and just applying the right tokens. With that said, we definitely at AMD are like super focused on applying those tokens to cover the entire breadth of software, from our ROCm EP to our client to cloud story, and just base enablement of the entire software stack to agents. Increasingly, we think it is going to be a very agentic world, and that is fast accelerating, and we are here to like support that. So with that, I think, I'll wrap it up. If there are any questions, happy to answer any questions. We'll see if there's. Cool. Thank you.